Hi guys, this is Juberi. Welcome back to my channel. In this video, we are going to cover what are the different types of data validations in pipelines. In the every modern organizations today, they depend on data, from banking transactions and healthcare systems to e-commerce recommendations and AI models. Everything relies on a high quality, trustworthy data. But what happens when the data entering your pipeline is incomplete, incorrect, or duplicated, inconsistent, or corrupted? That is where data validation becomes the most critical pillars of modern data engineering. So we will understand how companies validate data before processing, analytics, reporting, machine learning, and business intelligence. We also cover some of the example validation logics and use cases here. So whether you are a beginner learning ETL concepts or an experienced engineer designing a scalable pipelines, this video will help you understand the complete landscape of data validation in pipelines. The first one, we have the schema validation. Schema validation ensures that incoming data matches a predefined structure. This includes basically a column names, a field order, or a data types, and which are like mandatory columns. If there are using the JSON structures and nested structures, table contracts. So this acts as a first line of defense in any data pipeline. Without schema validation, downstream systems may fail due to unexpected columns, missing attributes, or data type mismatch. So schema validation is the foundation of reliable data engineering. Before even processing any incoming data, pipeline must confirm the structure matches the expected contract. Even a small schema change can silently break reports, machine learning models, or downstream systems. This is why enterprise pipelines validate fields, column names, nested structures, and data types before ingestion. In a large-scale cloud platforms, schema validation is often automated using the frameworks like Great Expectations, Apache Spark, or Delta Lake Expectations. Moving on to the next, we have null validation. This helps us maintaining the data completeness and reliability. Critical business fields must never be missing. In enterprise systems, missing values can affect billing, reporting, fraud detection, or customer analytics. So in the modern pipelines, automatically they identify null records, quarantine invalid rows, generate quality reports for engineering teams. And there are, in some cases, they'll also fill those null values with some default values based on some mathematical functions, like using an average value or a forward value or a backward value. So they'll do some this filling of those null values. And these validations, they ensure in that critical fields are not missing or stored with empty values, because down the reports they may be causing incorrect analytics or a failed aggregations or a business report errors or invalid machine learning predictions, broken downstream system joins. So these are some of the causes which we see during the null validations if you are not handling it properly. Next, we have the range validation. Range validation verifies whether numeric values fall within an acceptable minimum and maximum boundaries. It helps us to identify the outliers, sensor failures, or fraudulent values, incorrect data entry, or a system corruption. And this validation protects pipelines from unrealistic or dangerous values. Whether it is a financial system or a healthcare monitoring or IoT devices, acceptable value boundaries help maintain trust in the data. So outlier detections also plays a major role in fraud detection and anomaly detection system. Next, we have the business rule validation. This applies domain-specific logics to validate business requirements. Unlike journal technical validation, business rules depends on organizational policies and workflows. And these rules transform our technical pipelines into intelligent business-aware systems. This validation ensures that the data aligns not only with structure but also with organizational logic and operational rules. Every enterprise creates custom rules to enforce compliance, governance, and policy driven decision. Next, we have the format validation. This ensures the fields follow specific patterns, for example, like an email address or phone numbers or dates or zip codes, PAN numbers, other IDs. So this validation ensures that the structural fields follow standardized patterns. Incorrect formats can cause API failures, delivery issues, or authentication errors and compliance problems. So this type of validation is commonly implemented using regular expressions and rule-based parsers. Next, we have the length validation. Length validation ensures text fields meet defined minimum and maximum character limits. For example, we can have like mobile numbers must contain exactly 10 digits and pin codes must contain like 6 digits. So there are some specific rules. For example, like product codes must follow a fixed length rules defined by the company. So this length validation protects the system from incomplete or corrupted textual data. Fixed with identifiers are especially critical in telecom, banking, and government applications. This validation ensures consistency before records enter downstream systems. Next, we have uniqueness validation. This validation ensures duplicate records do not exist in a key identifier columns. For example, like customer ID must be unique in a customer report, or a transactional IDs cannot repeat. Invoice numbers must not duplicate. So these are some of the examples, but these duplicate data can create a massive operational problems from duplicate transactions to repeated customer records. Uniqueness in the validation protects data integrity and business trust. Modern pipelines use hashing, primary key checks, and distributed deduplication algorithms to maintain uniqueness at scale. Next, we have data type validation. This validation confirms each field contains that expected data type. For example, like integers, string, booleans, decimal, date, timestamp. These are all some of the data types, but where do we use it is like in the real world example, we have like suppose age, it should be an integer, and price should be an decimal. And for example, if any record is active or not, then those data type should be a boolean. So this data type validation ensures that every field contains value in the expected format and data types. Without proper data type validation, calculations or aggregations and analytics can fail silently. Strong type validation improves pipeline stability and downstream reliability. Next, we have a consistency validation. This ensures that data remains synchronized across systems and pipeline stages. For example, we have like where customer status should match across CRM and billing systems, or inventory counts should remain consistent across all the warehouses. So this validation ensures that distributed systems remains aligned. As organizations at scale across multiple platforms and microservices, maintaining synchronized information becomes increasingly critical. So consistency check helps prevent reporting conflicts and operational confusions. Next, we have the referential integrity. This validation ensures a relationship between tables remain valid. For example, if you have two tables, example like customer and order table should contain a customer ID. If a customer record is missing, then the relationship between this order and customer table becomes invalid. So this referential integrity validation ensures that relationship between the dataset remains trustworthy. This is one of the most important validation in relational database and enterprise data warehouses. Without referential integrity, analytics and business operations can become unreliable due to often or missing records. So in a modern enterprise, they combine all these multiple validation strategies together. A strong validation framework typically includes automated rule engines, real-time monitoring, data quality scorecards, alerting systems, and quarantine pipelines, audit logging, observability dashboards, schema evaluation management. And organizations also integrate into CI/CD pipelines to ensure reliable deployments and trustworthy analytical ecosystems. So, in the final summary, data validation is not just a technical requirement, it is a foundation of a trustworthy analytics, reliable machine learning, accurate reporting, and business confidence. From schema validations and null checks to business rules and referential integrity, every validation layer protects organization from poor quality data. As the data volumes continue to grow, automated and scalable validation systems will become even more essential for modern enterprises. Understanding these validation techniques is one of the most valuable skill for every data engineer, analytics professional and cloud architect today. So if you found this video useful, make sure to leave a like, subscribe, and share it with other learning data engineering and analytics friends. Comment below which validation techniques you use most frequently in your projects. And if you want more deep dive on PySpark or ETL pipelines, let me know the topic in the comment section so that I can prepare a video on top of that. Thank you.